With all that we've learned so far, it's super easy to differentiate sine squared x.
So I'm going to differentiate sine squared. Well, it's the chain rule, right? It's the derivative of the outside function, which is the squaring function. So it's 2 times the inside function, which is sine x, times the derivative of the inside, which is cosine x. So there, that's the derivative of sine squared x.
What if I wanted to go backwards? What if I wanted to anti-differentiate sine squared x?
I want to anti-differentiate sine squared x. I'm looking for a function whose derivative is sine squared x. Well, maybe my first guess for such a function might be sine cubed over 3. Because if I differentiate this, well, I'm differentiating the outside function, which is cubing. So it's 3 times the inside function squared divided by 3. And that's looking good. There I've got a sine squared x. The problem is that now I've got to multiply this by the derivative of the inside function, which is sine, and the derivative of sine is cosine. So the derivative of this is not sine squared x. It's sine squared x times this extra cosine.
Oh, it seems really hard.
Well, there's a so-called half-angle identity. This is the trick, that sine squared x is, according to the half-angle identity, 1 minus cosine of 2x all over 2.
Well, that's true, but how does that identity help?
Well, since sine squared x is 1 minus cosine 2x all over 2, that means the antiderivative for sine squared x is equal to the antiderivative of 1 minus cosine 2x over 2. Now to do this, this is the antiderivative of 1/2 times something, so I can pull out that factor of 1/2 and just figure out how to antidifferentiate 1 minus cosine of 2x. Now this is an antiderivative of a difference, which is the difference of antiderivatives. So I want to antidifferentiate 1, and then I want to antidifferentiate cosine 2x. Now what's an antiderivative of 1? Well, it's just x. And what's an antiderivative of cosine 2x? Well, one such antiderivative is sine of 2x, but then I've got to divide by 2 to compensate for the chain rule here. And I'll add plus c. So there we go. I could simplify this a little bit. I could write this as x over 2 minus sine 2x over 4 plus c. And there's my general antiderivative for sine squared x.
Maybe you really like this sort of thing.
Well, if you are really having fun with this kind of thing, here's a little challenge that you can play with. You can try to find an antiderivative, say, for sine to the 4th. Right? And if you don't like the number 4, you can make the 4 some other number, right? But it's pretty fun. I mean, you can try to apply some of the trig identities to replace sine to some power with things that you can currently antidifferentiate.
It's honestly pretty cool that these antidifferentiation problems are actually doable, that we can write down the antiderivatives.